write from one to the other. So we're going to start with recursive to explicit. So what does recursive give you? Like what does this first line tell me? The first term. Okay, so the first term so we know the first term is 3. Okay. And then the second line, what does that give me? The pattern, right? Well, what is the pattern? Plus 2. So to get from any term from its previous term, add 2. So in other words, what would the common difference be? 2. Okay, so that's what the recursive rule gives me. When I'm writing the explicit rule, the two things that I need, if it's expanded, right, expanded explicit rule, the two things that I need are the first term and the common difference. Do I have those two things? Yes, I do. What is my first term? 3. So where a of 1 is, I'm going to replace it with 3. This is just the formula, right? So then remember, this section doesn't change, so plus n minus 1. What am I going to write as d? 2. So that would be converting from recursive to explicit. Remember, again, we can write that 2 as a distribution in the front. So if we wanted to write 3 plus 2 times n minus 1, and I will tell you that it is written like this on your test at least once, okay, with the common difference in the front. So make sure that you have both of those on your paper, because those are the same. Yes.
Can you just leave it at the end as 3 plus 2n minus 2? You just want to leave it at
I would leave it in the parentheses. If you do 3 plus 2n minus 2, just go ahead and keep simplifying, because then you can combine like terms. And then you're in the simplified version. Okay, let's do one more together. We're going to do this one. So what does the first line tell me? Okay, so my first term is 8. And what does the second line tell me? What's the common difference? Negative 13. Okay, so let's write it the second way, where my common difference is in front of the distribution. So I would have C of n equals, what goes first? 8. And since it's a negative common difference, minus 13 times n minus 1. That's it. Converting. I'll catch up in a second. Okay, y'all do that first one on your own. C of n equals negative 22. Okay, n minus 1. I had a good question when I was walking around about, so since this is still explicit, we can find any term with explicit. So let's find one of our terms. Pick a position. 50. Okay. So if I'm trying to find the 50th term, what am I replacing with 50? N. Okay. So negative 22 plus 7 times 50 minus 1. Because remember, this is the same thing as our simplified version, we just haven't simplified it. Okay, so 50 minus 1, 49 times 7.
340.
Nice job, Tyler.
Okay, 343 minus 22.
321.
So B of 50 is 321. Now, if you're trying to solve for a specific position, like the 50th term, the 10th term, you cannot use the recursive rule. I cannot plug in 50 for n in the recursive rule because this is a term in itself. Remember, this is the previous term. So I can't plug in 50 for n. You cannot plug into recursive. Okay? Say it again. You cannot plug into recursive. All right. You cannot, because all recursive is telling you is the first term in the pattern. It's not one of the ones where you can plug in. Explicit is the one where it gives you more information. Okay, so let's flip to the back. We're going to convert from explicit to recursive. So I've got my explicit rule, and I'm going to break down what it's giving me. So it says f of n equals 5 plus n minus 1 times 16. Which one of these values is my first term? 5. Okay, so then what does that make 16? A difference. So when I write my sequence, or my recursive rule, I list my first term, so this shouldn't say b, it should say f. F of 1 equals 5. So f of n equals f of n minus 1 plus 16. So you're doing the same thing. Pick out the information that you need and replace it into a different formula. Okay, I'm actually going to skip example 2 for right now, just so we can try a couple the way that we had it. So looking at our first check for understanding, what's my first term? 5. So f of 1 equals 5. So then let's finish the recursive rule. F of n equals, I have to put the previous term. How do I write the previous term? F of n minus 1, not times, plus 12. Okay, now I'll do the second one. When I walked around, everybody had this. Okay, while I'm up here talking, y'all listen. Everybody had that, but that's just the pattern. Make sure you can't build a sequence with just a pattern, because a sequence doesn't always start in the same place. You have to know where it starts. So if you do not have the first term, you do not have the full answer, because I can't build something not knowing where it starts. All right? Okay. So now I'm going to go back up to this example 2. Yes.
Will we get fixed again if we use the wrong like variable, like here's g and the other one?
Oh, no. All right. If you start with simplified form, so slope-intercept form, 2n plus 10. If I'm talking about simplified form, what does my 2 represent? The what? The difference. Because it's what's happening every time. What's repetitive? The addition of 2. But 10 is not my first term. remember when you're building slope-intercept and then that whole first day on Friday, that's the y-intercept, which means that it's not f of 1, it would be f of 0. It's your 0 term, right? So there are two options. Option 1, you need the first term to build a recursive rule. So you could plug in 1 for n and solve. Or you could build your table, and since you know that 0 is 10 and your common difference is 2, what would my first term be? 12. Okay, so I could say now f of 1 is 12, and so f of n equals f of n minus 1 plus 2. But just be careful, because when you're comparing, let's say, your expanded and your simplified, you're given two different things, but one thing that remains the same is that common difference. Okay, so that's it's located in different places, but it's still your common difference. All right. Okay.